Welcome back. We are in week 4, and today we're going to be talking about, really going to be getting into interior construction. So today we're going to talk about the building envelope and all that entails with the basics of the beginning of construction for buildings. We will have a breakout session towards the end of class where you'll work in groups to do a little bit of research about roof types and systems. So that'll be again at the end of class. I think we had a really great discussion last week. You guys really demonstrated your knowledge of building teams, and I was very impressed by the conversations that were going on. So thank you for that. That was great. I hope that everyone feels like they learned a lot about the value of the building team and the members. I did want to say I did see some comments about lighting design and importance of lighting design, and how the lighting design class is not maybe part of the kitchen and bath program. So we will be talking about lighting design in this class. I think it's one of the most important factors of interior design is integrating lighting. So we will talk about it in some detail in this class, but definitely if you have an opportunity to take a lighting design class, I would definitely recommend it. I think it's something extremely valuable. I've actually only worked with a lighting designer a couple of times in my career on projects, so it typically does fall on the interior designer to know and understand the lighting. So, but yeah, we'll definitely talk about it and get more into it. And if you have any questions as we go through the coming weeks about anything, just feel free to let me know. Don't forget that there is that discussion forum in the general course or the general discussions for any questions that you might have that may benefit other people as well. So feel free to post there, and you can still post there anonymously if you need to. So today I'm going to share the screen. Can you all see the screen? So we're talking about the building envelope today. So we will have a little bit more of lecture today. Do feel free to jump in at any point and ask questions or steer the conversation one way or another. We're going to talk about regional considerations when we're talking about building, foundation systems, and then floor, wall, and roof systems. And we're really going to be talking more about framing systems for floors, walls, and roofs today. So the first thing that we want to touch on today are the regional considerations. And essentially, that really has to do with, we're really looking here at the United States right now, but that really has to do with what climate zone or what temperature zone a project is located in. Because depending on the zone, for example, if it's a very cold zone versus a zone that's very hot and humid, you're going to have different requirements for insulation and other factors if it's a very wet zone versus a very dry zone. So that can really affect the types of construction that happen. It can also affect, again, how much insulation might be needed in spaces. So this map just gives you an overview of the different climate zones in the US. You can see that a lot of the US is in that cold to very cold climate zone. So those areas are probably going to require more insulating materials to make sure that cold doesn't get into the building. We have kind of that mid-south area where it's mixed and humid. So it gets a little bit cold, also stays relatively warm, and probably has a little bit more wet going on as far as rain and precipitation. And then we have the hot humid, so that's the southern region. And just because it's hot and humid there most of the time doesn't mean that those places aren't also susceptible to some colder temps. I think we've seen a lot of that happening in Texas with ice storms and things like that. But in general, those areas in the south are considered more of the hot and humid areas. And then South of us, kind of through that, what we call the desert region, is more of the hot and dry or mixed dry. So much more, whenever you have humidity, it changes temperature. So if you have humidity, it's going to drastically increase how hot it is or how cold it is. And when in the drier climates, like where we are, it's going to be more of a true hot or cold. And then the marine area up on like the west coast is really that where it can get pretty cold and very wet. So all of these are just examples of the different climate zones and understanding the variations between each zone. And that's going to lead us into our next topic, which is R values. So the R value, essentially it defines how well an insulating material works to retain its thermal resistance. And the greater, so the colder the location, the higher the R value needs to be to insulate a building or a structure. So again, it will depend on the climate, how much insulation is needed or required, and what type of heating or cooling system might be used. So this area over here is going to just give you an idea of the different zones. They're broken up into 7 different zones. And then R values, which are the target R values for each type of framing. So attics would have a higher R value than, say, wall partitions, which would be either 2x4 walls or 2x6 walls. And then we have floors and crawl spaces. So you can see that throughout here, some of these states have more than one zone. And for example, you can see Colorado right here actually has 4 zones. We've got zones 4 through 7. So we have areas, different parts of the state that require different R value ratings. So just also something to know and understand as part of how we keep heat in or keep heat out, so to speak. Any questions about R values or insulation? We're going to talk more about insulation in just a second. So this is your typical, this is a good example of a wall section detail. So here you're seeing the exterior of the building. This is brick or masonry detail. Then we have a drain cavity so that moisture can move away from the structure. We have, in this case, this is probably in a colder climate because there is a exterior rigid insulation or foam insulation panel. So you'll typically see that in climates that need higher R value ratings. And then we have our membrane, our air barrier and vapor barrier, which we'll talk about in a minute. And then we have our sheathing. And then once we get inside the structure, this is the area where the insulation would be. So typically insulation goes into the stud walls, and there are several different types of insulation. There is the batten rolls, which are like the pink insulation that you may be familiar with. Anybody might remember Pink Panther was a brand of batten roll insulation. They had the Pink Panther as their mascot. There's also blown in insulation where you can actually take insulation and blow it into the cavity of between the studs in the framing. And that can be, give higher insulating values. And then there is the expanding foam insulation where you spray it in and it expands and adheres to everything around it. So it depends on, again, on the climate zone, what type of insulation you might see in a project, but essentially they all work the same way. They work to, like I said, either keep heat in or out. And so there are 3 heat flow mechanisms when we're talking about heat and how it travels. So conductive is where heat moves from one thermal mass to another. So it could move through walls to floors or things like that. It's not, it's through materials, not ambient in the air around you. And then the convection is the flow of heat within fluids or gases. It could be in the air, it could be in water as well. And then radiation. So that's when heat radiates throughout a space through electromagnetic waves. And the sun is an excellent example of radiant heat source. So we receive heat from the sun, it's radiating out into the atmosphere. So most commonly in insulation, it's working by slowing down conductive heat flow and reflecting that heat back so that it maintains the proper temperature inside. Any questions about insulation? So in addition to insulation in buildings, we also want to find ways to keep buildings dry, not only for insulating factors, but also for indoor air quality, which we'll talk about in the coming weeks, and just basically designing healthy spaces in buildings. Wherever water can go or gather, it can cause molding issues or other issues, can cause decay to stud framing, things like that. So the important part of keeping buildings healthy and safe is keeping them dry. And the best way to think about an air barrier versus a vapor barrier is, for example, if you were to wear a wool sweater, it would keep you warm as long as it was dry. If you're wearing your wool sweater and it starts raining, you're going to get wet. So to protect yourself and keep yourself warm and dry, you might combine, say, wearing a wool sweater with a raincoat over it. So that's really how air barriers and vapor barriers work. The air barriers, they keep things, they restrict heat loss and gains, so they help keep the temperature consistent. While the vapor barriers really prevent that, prevent the structure from getting wet or retaining moisture. And this is just some helpful information. As interior designers, we don't specify a lot of these exterior type of materials, but when it does become important is when it determines how thick a wall might be because of what type of insulation needs to go into that wall or what other systems might be happening in the framing structure. So that could impact your interior space or your finished dimensions for finished widths. So it's good to know what the parts of the wall are and how they work together to make the overall thickness or depth of the wall. Any thoughts or questions about regional considerations? I don't want to go into too much detail on that. So let's talk about foundations, because really buildings need a strong foundation in order to support them. And I think we explored a little bit of that last week in the building teams discussions when we were talking about structural engineers and how important they are to a building's integrity and structural integrity. So foundation really goes hand in hand with those structural engineers. And it's really the load-bearing portion of the structure. It bears the weight of the building. And in some cases, it also depends by region. So it may be built below ground, or it may be just on grade or on the surface of the ground. But despite however it's built or whatever type of foundation we're talking about, it must support the structure above, keep out the groundwater, and act as a barrier to water and soil vapor. So soil vapors we're going to talk about when we get into indoor air quality, but there are vapors and gases within the soil that can seep into buildings if they're not properly maintained or don't have the proper barriers in place. So again, those vapor barriers are extremely important, not only in keeping buildings dry, but also keeping those toxic gases out. So foundations can reduce your utility bills. They can potentially avoid costly problems like moisture collection or termites. In some areas, termites are very prevalent, and having a solid concrete foundation versus wood construction is going to be better. You can help create more comfortable living spaces above the foundation because you can insulate, again, below the foundation or below the floor, between the floor and the foundation, you can add an insulation layer. And then again, we can help avoid health risks with the gases in the soils. And in areas that are able to use basement foundations, you can add, you can expand the living area or the living space or the usable space or occupiable space in a building. So we have a lot of basement foundations here in Colorado. And essentially, they typically dig a hole about 8 feet deep. Sometimes it depends on the soils. This is where that civil engineer is going to be important because they're the ones that are looking at the soil, the integrity of the soil, and how it can be moved and what its properties are and if it can withstand a basement foundation. I will say that in Colorado, we do have a lot of bentonite in our soils. So we see a lot of soil shifting happening, and that can cause cracks in foundations and then make them structurally unsound. So it is important that all of those soil tests are done ahead of time, and that it is recommended that a deeper foundation can be dug on the land where it's being proposed. So again, basements, I think everyone is familiar probably with what a basement is and the additional living space that it can provide. The cons about a basement are it needs to be sealed and insulated all the way around the foundation so that you don't lose that, you don't either lose or gain heat. And in the flood prone areas, you need to install they need to install a sump pump in the basement in case there is a flood. That helps get water out. Again, water is really bad for buildings and construction. So we're always looking for ways, best practice, to keep things dry. And again, soil can really affect whether or not you can have a basement. Also, if you're working on a project where you're adding a basement or it's a new construction and there's a basement and you want to have bedroom spaces in a basement, they need to have an exit window. You need to have an escape route if there is going to be habited sleeping areas in a basement. So sometimes in older homes, you'll see basements that just have these teeny tiny little windows kind of up high at the top of the foundation line where just above the ground level. And so you would not be able to make that a habitable room if it didn't have an escape window. So typically when you're going to have that escape window, you're going to need this deeper well dug out. And typically the window well will come with a ladder or something for you to be able to climb out of those instances for egress.
Hey, Shell, I have a question. It seems like every house I've lived in, even in like houses that were built really high, it seems like there's always a sump pump anymore. Is that just pretty standard even in non-flooding areas?
You know, I think I've seen them a lot. I don't have a sump pump in my basement currently. So it may just be because of the grade issue. If you're on a hill or something and water could flow down, that could contribute to needing a sump pump more than if you're maybe at a flatter grade level. That's all I can really think of. I know we don't get a ton of flooding here in Colorado, but there are instances where if your property sits at a certain slope, you might have water collecting.
It just seems like if they're not that expensive, why not just put one in anyway? You know?
Because sometimes they take up valuable real estate or room. So it would really come down to planning where they go. Like, be good to put them in an area where maybe the furnace or water heater or other things are that you can put off into like a separate room. A lot of times I see them just put anywhere, and I don't know what the reasoning is behind that. It probably has something to do with civil engineering, but I would say if there is going to be one, it would be good if you could coordinate where it's located so you can get the maximum use out of the space.
And then I have a quick question as well. So thinking about this, I'm thinking about Flatirons Mall, where they have torn down a lot of buildings already because of the soil. Now, I don't think they're going to tear down the whole mall, but because they've built this huge structure on this property, how would they go about fixing it so it doesn't, so they don't have to tear it down?
I don't know what type of construction they have at that mall, what kind of foundation. I'm assuming it's probably a slab foundation, would be my guess. And I can't answer how you go about fixing those problems. I know that Colorado has those shifting soils, and it's not uncommon to see those problems, but that's really where probably they need to get a structural engineer involved to do a survey and come up with ways to make it more structurally sound. I didn't even know they were tearing buildings down related to the mall. So that's
interesting. Yeah, they took out Chipotle, they took out all these shops on the outside where like Red Robin is, and it's all just like community area.
Like green space kind of?
Yeah, there's like picnic tables and cement and
interesting.
Yeah,
that seems like a lot of money was wasted, and maybe they didn't do their due diligence before really doing that project.
Shell, what did you say the soil content was predominantly made of in those areas?
In Colorado, we have a lot of bentonite in our soil. And we also have a lot of clay type soils. So that can affect moisture content and shifting as well. So it really just depends. Although I do see a lot of basements in Colorado, more so than say, Texas is a great example. You don't see a ton of basements in Texas. Also, they're very close, to sea level. So flooding could be a huge issue there, could be part of it. But you don't see a lot of basements in places like that. But we do get them here. So it has to probably do with our relatively low precipitation annually, I would assume. But I do know, I think I might have mentioned this to someone last week. My mom was selling her house a couple of years ago, and her basement foundation had huge cracks in it. That happened almost immediately after the house was built in the 90s. And they did have a structural engineer come out and assess and fix the house in the late 90s, right after it was built. But when she went to sell it, she had to get another structural engineer to come out and evaluate it and write a report stating that it was repaired adequately and was safe so that she could sell the house. So it can be problematic if it's not addressed early. It can become problematic for sure. And soils are always going to shift, and there's always going to be some movement. That's why they put those scoring lines or break lines in concrete, is for those stress areas, to give it a little bit more relief, because the more rigid a material is and the bigger it is, when the soil shifts, it's just prone to cracking anyway. So it really just depends on the size of the crack and how deep it is before it becomes a structural problem. Another basement type you might see here in Colorado, even in conjunction with a basement, is the crawl space. The crawl space also can be referred to as pier and beam foundations. This is generally where you have what's called a foundation footing, and they built up these piers or stilts that elevate the building up off the ground. So typically, crawl space foundations are about 24 inches deep. They can be a little bit deeper. I've seen them I've seen some areas where it probably has something to do with the gradation of the land, where there's a crawl space in one area of the basement and then a bigger, larger, livable basement space as well. I've seen crawl spaces up to like 5 feet tall. So crawl spaces are great because they get your building up off the ground and away from that moisture. So these are really good for flood zones, to protect a building and make sure they stay dry. You can also, in that area, you can use it for storage. It's a great place to run systems, so electrical wiring, plumbing systems, things like that can all be run through the crawl space area and take up less room in the walls and other areas of the building. And then, depending on your climate, it could you could need to add a vapor barrier if you have a crawl space. A lot of times you'll see crawl spaces will be unfinished, but they will have that plastic sheathing or barrier over the dirt so that you're protected from the gases in the soil again and keeping things from collecting moisture. So again, you see these a lot of times in areas that might be prone to flooding that need a little bit of elevation up off the ground to help keep the building dry. Any questions about crawl spaces? Has anyone ever been in a crawl space?
We have one. It's probably about 4 feet high, and I wish we could dig it out and expand our basement, but I don't know if that's possible.
You know, it might be. It would probably be the structural engineer to tell you that, but it might be possible to dig it out more.
I dug out my last house and did that. So half the house was finished, the basement was finished, and the other half was not. And we dug it out, poured a concrete slab, put in radiant heat flooring, soy spray insulation in that part, and added 1,200 square feet to the house, to the footage of the house. So it made a big difference. And the present house I live in has a crawl space with the vapor barrier, but the floor is not insulated, and it needs to be. But like, it holds the Halloween decorations.
Like here in this, in the floor and the space.
Yeah, that it needs to be insulated there. And there's a sub pump down there with an alarm system on it. And the reason why this house is on a crawl space is because we're low on the table and we're prone to the water table. So we're prone to flooding in where we're located at the bottom of the valley. The HVAC system, this is the unfortunate part, is that when you want to change your filter, you have to crawl to it to go change your filter. So that's a poor design on that part of it. But otherwise, it's just a trap door in the Harry Potter closet that you go down to the crawl space to get the Halloween decorations.
Do you have lighting down there, or do you have to use a flashlight?
Yeah, there's lighting down there. And in the last house too, it had electrical, and it was probably how tall? It was like 6 feet. We had to dig it out a bit to get to code. And then we had to put in a structural beam as well for support because we needed to get more support down there. But that was quite a project. But everything that I just read about in the books, I was like, oh yeah, I had to do that, put the piers in on the outside to support it and get the structural engineer in there to code it. It was quite interesting.
Yeah, yeah. I mean, a lot of times I do see lighting. It should be easy to get lighting in a crawl space. So a lot of times I do see just, it's usually just a socket where you can screw in a light bulb, but typically they are lit. So you don't have to crawl in there necessarily in the dark.
We have been growing up and my parents had to use snakes all the time, like plumbing snakes down there. That's where all of our plumbing was. We had an old house. It was my great-great-grandma's house.
Oh, yeah.
And there was no barrier.
Oh,
dirt.
maybe because it was older.
Yeah.
Yeah. One other thing about cons for crawl spaces is, things can crawl in there. So depending on exposure to outdoor elements, animals might be able to get in there. I know in my mom's crawl space, she had some baby bunnies that were born in there. So that's just another potential thing that might happen, or rodents can be prevalent maybe in crawl spaces as well. So any other thoughts about crawl spaces? So then slab on grade foundations, these are literally just concrete that's poured 6 to 8 inches thick on top of the slab surface. Typically, there are some preparations involved, which include gravel, which helps facilitate drainage. Depending on the climate zone, you might have that rigid foam insulation between the gravel and the slab. You see a lot of, in Colorado, the best example I can give you about slab on grade is your garage. If you have a garage, that foundation or that concrete floor that you pull into park on, that's a slab on grade foundation. So if you don't, the other thing to consider about slab on grade is in freezing climates, such as Colorado, you need to have that rigid foam. And you also need for the post and the pier, the footing to go below the freeze line in the soil so that it doesn't risk cracking and ruining the foundation. And there's no open space, obviously, below a slab foundation. So that means that all those pesky rodents or bugs, don't really have a chance to get in there. It's pretty sound. They don't rely on any beams for support. They are all supported by the footing system. And very minimal digging needed because, we're only talking about 6 to 8 inches of slab plus whatever the minimum requirement is to get below the frost level for the footings. So they don't take a lot of digging, which can make them more affordable as well. The cons are obviously you can't get underneath them to run any of your utilities. You could have problems with freezing, just like I was just talking about with concrete. The bigger the piece of concrete and the less stress expansion joints are added, the more risk for cracking when soils do move. And they're also a little less ideal in flood prone areas because they're just literally right there on the ground and can absorb all that water. So essentially slab foundations are just that sheet of concrete across the entire base of the building. You see this a lot, slab on grade a lot in commercial buildings as well. You don't see a lot of basement structures in commercial buildings. Sometimes you'll see lower levels in commercial buildings, but oftentimes you'll see slab on grade on the main level.
So then in places like California where they have lots of, well, I guess they don't have lots, but like earthquakes, I know they don't have basements because of that reason. Then what kind of foundation do they have?
I think they have a lot of slab on grade, or in areas that are closer to the water, they probably have a lot of those crawl space or pier and beam foundations, just to make sure that they don't have flooding issues. I think it would depend how coastal you are versus inland in California to determine that. They don't really have the freeze factor there either, so.
Is a slab on granite, is that also referred to as like a pad? Like, do you think in the...
Yeah. We refer to
Yeah.
it. And then in addition to the slab on grade, sometimes in commercial buildings, they'll also do what's called a drilled pier foundation. So they'll literally drill into the ground these huge shafts or caissons that they fill with concrete, and then that supports the building. Those can range anywhere from 24 inches to 120 inches in diameter and go as deep as 300 feet. So that's also going to depend on the soil stability, probably how large the building is or what it's supporting. Those big, huge, tall skyscrapers, they're going to need a lot of deeper foundation support. So in commercial, you might see a drilled pier foundation and then a slab poured over on top of that. Any other foundation questions or thoughts?
When we were looking at houses, we saw a lot of basements that had floating floors. It was like a subfloor instead of a cement slab because I think it had bentonite soil.
Mhm.
I'm not sure how those are constructed, but
Yep. So
it made me nervous. I didn't want to buy a house with a floating basement floor. I don't know why, but
oh, I think they're actually they're okay. And actually, if you float the floor, so that just means that you're going to have a framing system on top of the slab that elevates the floor up a little bit higher. Typically, your basement will be a little bit warmer because you can insulate again between the concrete slab and the floor surface. So I wouldn't be too concerned about floating floors in basements. But you're right. I do see those in a lot of bentonite areas where there's more shifting because of the scare of the foundation floor cracking. So let's talk about floor construction systems or floor framing systems. I have a video. This gives you a pretty good overview of the basics of the components of a floor framing system, and then we'll talk about them in a little bit more detail.
While the foundation supports the weight of the building, it's the floor frame that establishes the level and squareness of the finished structure. To begin, let's look at the elements that make up a basic floor frame.
In residential construction, the floor frame is supported by the foundation walls, along with any support posts and girders that span the interior of the basement or crawl space. At the base of the floor frame, directly on top of the foundation walls, are the sill plates or mud sills. The sill plates are attached to the foundation walls using anchor bolts embedded within the concrete. A sill sealer is installed between the plate and foundation wall to keep out insects and prevent drafts. The sill plates provide a flat, level nailing surface for the installation of the floor joists. To complete the floor frame and tie the joists together, rim or band joists are attached to the open sides of the frame. Depending on the span of the floor joists, a girder or beam may be required to support the interior of the floor. To help stiffen the floor and spread concentrated loads over a wider area, many floor frames include bridging between the joists. To complete the platform, the joists are covered with either a 5/8 or 3/4 inch thick subfloor.
The first step in building a floor frame is determining the size and type of joist to be used. Now, this will depend on several factors, including the building span, cost considerations, and your local building codes.
So this is a good diagram about what they were just talking about. So you can see the foundation wall here, and then the sill plate. So the sill plate is typically wood, and that attaches to the foundation wall and gives a place for the joist to anchor to. The joists are going to run perpendicular to the sill plate in most instances, obviously not in all. And then you have your studs here. This is your stud wall framing, and then you have your floorboards or subfloor here. And then they're showing baseboard in this image, but you would have a finished floor surface before you would install baseboard into a room. So again, the sill plate, it's usually a 2x6 lumber that's used and bolted to the top of the foundation. He did mention that sealant that they use between the sill plate and the foundation to, again, keep air leaks from happening and keep bugs from being able, or insects from being able to get in there. The rim joist, band joist, or in joist, that's going to be the board that's equal in height to the floor joist, and it sits even with the outside of the edge of the sill plate. And then the floor joists, which are shown here, those are typically 2x4 or 2x6. It can even go up to 2x12. So 2x4 would be 2 inches thick, 4 inches wide on the face. So 2 inches by 4 inches, and that's nominal, which means average. The typical height or the typical dimensions will be just below that. You know, might be 1 3/4 inch by 3 3/4 inch. They can go all the way, like I said, up to 2 by 12. So obviously, the larger the joist, the bigger and the more open floor area you can have. So if you're looking for that really wide open monolithic space that doesn't have a lot of supporting members, you would want to they would want to use a bigger floor joist in that construction. The bridging that he was talking about isn't shown in this, but you know, bridging would be where you have connecting pieces to help strengthen those floor joists so they don't start bowing or bending, especially if they're going across longer spans, wider spans. You might need bridging. And then the floor sheathing or subfloor, again, that's laid on top of the joist, and then you would put whatever your preparation material as needed for your finished product of flooring. And we'll talk about those materials and finished materials as we get into interior fit out and construction in a couple of weeks. So if you are considering volunteering for the Habitat for Humanity construction opportunity, you might get to see some floor construction happening, or you may get to see where they've already framed the flooring, but they're starting to frame the walls around it now as well. So if you do, hopefully once you start to see that in person, you can relate it back to this image and sort of be aware of what each component is and the role that it plays. Any questions about floor framing?
I have a question in regards to if you're putting in like a larger bathtub that's maybe going to hold more than your regular standard bathtub. What sort of things and how easy is it to get to those studs to make them stronger to carry that weight?
You might need extra bridging, or in a minute we're going to talk about floor trusses, which have extra structural support. And my guess would be you probably would use a floor truss in that space to burden the weight. So in commercial buildings, you oftentimes will see this lightweight steel framing or steel framing instead of wood framing. Sometimes that has to do with fire codes or fire prevention. Sometimes it's just because it's stronger and it can hold more weight. So if the building's taller, typically you're going to see more steel construction. So again, they can hold a lot more weight than wood products. They are fire resistant. You don't have any concerns when you're using steel construction about insect infiltration or rotting or water damage, things like that. Steel's not a very warm material, so it might need to be extra insulated to keep spaces warm. And typically, so wood framing construction wood framing pieces can be cut at site by contractors, where steel framing, they typically need to know all of those dimensions up front, and they're cut in a factory and then shipped to the site. So those are just some differences between wood framing and steel framing. And like I said, more than likely you're going to see wood framing in residential construction and steel framing in commercial. You might, in some commercial buildings, see a combination of wood and steel framing, but typically the first floor of a commercial building will be steel construction, and then you might see wood framing on the floors above. And then to those trusses that I was just talking about. So these are designed to hold weight for longer spans. And that means that you don't need as many walls. You can really have that open space. These are the strongest options. So if you are looking at, Laura, maybe using a heavier tub, this probably would be something to consider. Because trusses have these crossbars, they create these openings where you can snake wires or plumbing fixtures or pipes, which makes it nice for, you know, getting systems running underneath the floor. And they're very customizable. So they're designed and then ordered to your spec. So they can accommodate a lot of things. You not only see trusses in floor framing systems, but you also see them in roof framing systems as well. So again, they're great for access and navigating ductwork or those HVAC systems, electrical systems, plumbing systems. They're definitely more expensive, and they need to be special ordered. So they might take a longer lead time, which could contribute to your project schedule. So, but again, as designers, we're not really specifying these materials. We just need to have an understanding of what they are so that when the rest of the building team is discussing them, we know what's going on and what our limitations are as far as how open a space can be or how many load-bearing walls we need to have to help support the roof structure above. Any questions about floor construction or framing for flooring?
I have a question, Shell. This image on the PowerPoint, would that be in a commercial structure, or when would you see that kind of space in between a floor joist or in between floors?
You could see this in a commercial or a residential. It would just depend on, again, the building and how expansive you want this floor space to be without any limitations of walls. I've definitely seen this in commercial buildings as well, but typically, even in residential, you're going to see about 12 inches of space between the top of the ceiling and the next finished floor. So it wouldn't be unusual to see this in a residential environment either. It might be, you know, a larger house, or maybe it's a house that doesn't go up as much, but that's wider, more of like a ranch style that needs to distribute the weight more evenly, something like that. Just depends. And it also could always come back down to cost, because you can get some of these attributes by using the bridging in the regular stud or joist system. So it could be a cost. It could be something that comes back to cost for whether or not they decide to use trusses over joists. So wall construction is very similar to floor construction or floor framing. We're still talking about wood stud framing systems. So we're still talking about using either 2x4 wood material or 2x6 wood material, typically for exterior walls. That's going to be, again, based on the regional considerations for the project, how much insulation is needed, and things like that. Most commonly, what I've seen are 2x6 stud frame walls on the exterior of a building, and then 2x4 walls on the interior. So you can really get that extra insulating factor on the exterior. There's two approaches to framing, wall framing. There's the traditional framing approach, which uses the 2x4, the 2x6 wall studs, and spaces those studs 16 inches apart on center. And what that means is it's from the center of this face of this stud to the center of the face of this stud is 16 inches. You can almost always assume that studs are about 16 inches on center if you're working on 1- and 2-story buildings. And again, 2x4 material, that's going to define how thick the wall is. If you're using a 2x4, you're probably going to end up, once you add your gypboard and any other finishes, you're probably going to end up with about 4 3/4 inch deep or thick wall cavity. In 3-story buildings, or above, like say multi-family buildings or apartment buildings, condos, you cannot exceed the 16-inch on center spacing for your stud placement because the building has more weight to bear. So you need to have more of those studs holding it up. But there is something called advanced framing, where in smaller buildings that are shorter and less structure, you can use the advanced framing technique, which will allow you to expand your spread of the studs and place them 24 inches on center. Now, sometimes as designers, we need to know where studs are because we have something we need to mount to the wall that's heavy, and we need to go into that wood stud to really secure it. So it's good to assume, again, that they might be 16 inches on center. If you measure and you do a test and put a nail into the wall and you don't feel like you're hitting, it's not dense, then you might be a 24-inch on center. There also are stud finders available that help you locate studs. But we're going to also talk about another way to approach providing that anchoring without having to locate a stud. So again, 24-inch on center, that's the advanced framing technique. I do have a video next that's going to show you some of the best practices when using advanced framing and how it can help with climate control and things like that. If you're working on the exterior of a building or a house and you want to have penetrations or openings, you'll see in both of these examples here, we will have, they have what is called the extra stud. The king stud is really the stud that's going to be supporting where you're opening or penetrating the wall. And then you're going to frame your opening, whether it's a window or a door. Either way, you have to have what's called a header. So that becomes a horizontal stud that lays across the top of the opening. And then in the case of a window, you would have a sill. So that would create your window opening. And then you would need to have extra crippling studs to support that opening. In advanced framing, you can get away with a lot of this extra stud framing because you're using stronger techniques, and you just need the king studs and a single, a cripple stud, depending on the size of the opening here. So there are advantages to the advanced framing. They can be more sustainable because you're using less lumber and having less waste. But again, you can't always use advanced framing in every scenario.
The advanced framing using a 2x6?
Yes.
Okay.
2x6. But again, I see a lot of 2x6 framing happening on exteriors anyway, so you can use it either with this conventional or advanced framing. You don't have to use the 2x6 with the 16-inch on center, but I do see that a lot in exterior walls. So when we're talking about penetrations or openings, openings that are 3 feet wide or less can be supported generally by double studs, 2 studs that go vertically, and 6 feet wide or greater, they need to have triple support studs at each end and a stud at each end to support that opening. And we're going to talk a little bit about roof structures later, but a gable end wall is essentially that triangular wall that makes the roof form. So the studs at the gable end walls, they bear a lot of the weight of the roof. And so they need to be notched and nailed to the end of the roof rafter. But again, we don't specify this. We don't typically draw framing plans. That's typically an architect's scope of work, but good to know when you're looking at a building or if you're walking a new construction building, you kind of get an idea of the different framing techniques. So to go into more of the advanced framing, this is Matt Rinsinger, and he posts a lot of great videos about construction methods and construction techniques. And he actually can help guide you a lot in the best practices. So you may want to start looking at some of his stuff for your best practices booklet that's due at the end of the semester. He has a really great hand on construction, and a lot of his projects are in Texas. So you will see some different variations of some of the things that we talk about based on the location of his projects. But he does a really good job here explaining the advanced framing technique.
Hi, my name is Matt Reisinger of the Reisinger Homes. Welcome to my video blog dedicated to building science and fine craftsmanship. I want to talk about practical advanced framing on this video. But before we get to advanced framing, I want to show you what standard framing looks like. I'm in a 1950s house that my company is doing a deep energy retrofit. And this is all the original framing on the house. This is 2x4s that were framed in the 50s. You can see these 2x4s are in 16-inch centers. And interestingly enough, this house had an addition added about 10 years ago. And the framing on the addition, besides the lumber looking a little yellower, looks exactly the same. So let's walk back and I'll show you that. And then we're going to talk about a few of the things that we're going to do differently for advanced framing. So number one, this house, 2x4s on 16-inch centers. Look at these headers on here. These are the headers that were added about 10 years ago when these windows and this addition was framed. A ton of lumber in those headers. Lumber does have some R value, but it's quite minimal compared to the foam that we've sprayed in those cavities. And then lastly, I want you to notice this 3-stud corner. This is a traditional 3-stud corner, and we've air sealed it. That's what this gray caulking is right here. But really, with a 3-stud corner like this, we have basically no insulation in that corner. Now, my spray foam contractor has drilled these and tried to add some insulation there. And we've also done some rigid foam on this project to help with that. But I wanted to show you what standard framing looks like and some of the issues that you come across when you're framing fairly standardly. So now let's go out to a new construction project that my company's building, and we'll show you what practical advanced framing looks like. Advanced framing. If you've not heard of advanced framing before, the idea is that there's so much lumber in a house that actually most houses are probably overframed when it comes to the amount of 2x4s, the amount of lumber or structure in the house. And so advanced framing is about reducing the amount of lumber in the house in a smart way. So what I'd like to focus on today is kind of practical advanced framing. In this house, we took an approach that is not quite all the way, but I think really makes sense for most people that are building a new house. I'm here in Austin, Texas. This is a cooling dominated climate. We do need some insulation in our walls, although not nearly as much as some other climates like the Northeast or in really cold climates. But I do prefer to frame all my houses with 2x6 exterior walls. And one of the first things we want to talk about when we're talking about advanced framing is the distance between the studs. These studs here, these 2x6s, are in 24-inch centers. So it's 24 inches center to center in these studs. Most houses are framed 16-inch on center, and that's unnecessary. 24 inches on center is plenty. A couple things about that I do want to mention. I'm a big believer in a full exterior sheathing on the house. So you can see here we've used OSB on the outside of the house. I'd actually prefer to use plywood. So I did use pressure treated plywood on the first 2 feet of my house. We're on slab on grade construction here. So this is a cement slab we're standing on. So at the lower part of the grade, pressure treated plywood in that area, which is a little more vulnerable. Then we switched to OSB from there up. I'd prefer plywood, but we just didn't have it in this particular project's budget. You can see how our floor joists up there, these are 2x4 trusses that we've used for floor joists. They've landed on a stud nicely. And then our headers, actually, let's pan over here and show you one of the headers. Our headers are mainly timber strand engineered headers. I'm a big fan of these. We do have a few LVL headers in some other places, but when we frame with a 2x6 exterior cavity, that header fits in basically a 2x4 space. And so it leaves us 2 inches from that outside face of the header until we hit our sheetrock. And if you look over here, we've started to insulate this header cavity. And that's one beauty of 2x6 framing is now I can use insulated headers. So this is 1 layer of 3/4 exterior rigid foam. We're going to add 1 more layer of 3/4 and then a 1/2 inch plywood on top of that. And then everything will be nice and flush. And that will actually be an R10 header, which is fantastic. The second very important point on advanced framing, if you scroll over to this corner, is how we do our corners. If you pan around here, you can actually see on the inside of this corner here. This is something that's commonly referred to as a California corner or a two-stud corner. You can see that our stud is way back here on this corner, and then we've added this stud, frankly, just as a drywall backer. That could get eliminated in favor of drywall clips, but I'm just not sold on that process, so we put a stud in there. And then we're going to do a total fill installation on this cavity. I'm actually going to use Owens Corning Energy Complete. So this entire cavity is going to get R19 packed full of a blown-in blanket. Really good insulation system. On the outside of the house, we're doing 3/4 inch rigid foam. So that's just a brief rundown on advanced framing. And again, the two most important things in my mind are going to 24-inch centers, doing these California corners, and then if you can switch to 2x6 construction, it makes a big difference. Really like exterior sheathing. And last, when we install drywall, I really prefer to use 5/8 inch thick drywall instead of 1/2 inch drywall. A lot of advantages to that. But the big one is when we go to advanced framing on 24-inch centers, it's a much stiffer product. We typically do smooth wall in all our houses, so we have very smooth drywall. We're not using texture. And that 5/8 rock, sheet rock, is much stiffer, gives a much straighter wall, and looks better in the finished product. And when we're going to 24-inch centers, I think that really makes sense to use that 5/8 sheet rock. It also ends up with a little bit of a quieter house because we've got a little bit more mass in our wall cavities. I think that's about it. Thanks for joining me, everybody. And if you're building or remodeling, please think about doing some practical advanced framing in your project. It makes a big difference. We're going to pack a lot more insulation in this house than if we would have done standard framing practices. And ultimately, there's a benefit to both the builder and the client in saving some of that additional lumber that wasn't really necessary. Talk to you soon.
So some of the important factors that I picked up on that he was saying were insulating around the window framing. So anywhere that you penetrate a building, that's obviously going to have opportunities for air leaks. So the advanced framing gives you that opportunity to add extra insulation around the window header and really seal that area to avoid air leaks. It's also, can give you those higher R values that you need to achieve. And it's more energy and green conscious. You're using less lumber, and you're able, again, to add more of that insulation in that California framing corner. So, but again, 24 inches on center is not adequate for all areas. So you'd have to refer to the local building code to know whether or not it was acceptable in wherever a project is being built. But if it is something that that can be done, it would be good. He also talked about OSB, which is Orient strand board, which is similar to plywood, but just not quite as strong versus plywood. And so OSB is typically used a lot in residential for exterior sheathing. That goes and protects the insulating factor. But plywood can also be used, again, like he was saying, it's just a cost issue at times. Any questions about advanced framing techniques?
How long has advanced framing been around, and is it going to become the new code or standard for building?
I don't know how long it's been around, but I don't think it will become a standard because I think there are still areas where it's not adequate enough to support a structure. So even in areas like California where they're prone to earthquakes, they want to have more framing materials to support those structures. So I don't know that it will become the best practice for every building or every consideration, but I think when it can be used, it's the best way to approach, if that makes sense. Anybody else? So we were talking about locating studs, and if you have, say, especially in kitchen design, you will be installing kitchen cabinets in your designs, and those need to be secured to a stud, or they need to screw into a wood wall. So if you can't find a stud, or a stud isn't available where you want to hang something that's heavier, like a cabinet or other millwork item, even artwork sometimes, heavy mirrors and things, you'll want to secure those to a stud. If you can't connect to a stud wall, you can add what's called blocking into the wall. Now, this is something that as a designer, you want to prepare for and include in your drawing documents. So anywhere that you're going to be hanging something that's heavier, that may or may not hit a stud, you want to specify for blocking to be added into the wall. So blocking is literally just pieces of wood. Generally, it's leftover scrap wood from studs or other forms of, maybe it's some leftover plywood or OSB or something like that, that gets put between the studs and provides you a place to secure and gives you really that whole range so that you can secure those items safely. This video just gives you a closer look at what blocking is and some ideas of how it's used.
4, 5, 6, 7, 8 corners here. I don't know about you, but have you ever taken a picture or a heavy frame or a mirror or something and tried to apply it to a wall, and you go along and you're tapping against the drywall and you're trying to find a stud to drive it into a nail because this thing is so heavy it's got to hang on the infrastructure of the house like a stud like this, but you can't find it and you're just going along putting holes in the wall. Well, I hate that. And when you know you're going to have something heavy hanging on the wall, there are ways to think about it. You know, again, this idea of plan in the beginning with the end in mind. And I know very well that what I'm going to do here, this is the kitchen in the house. I know the refrigerator is going over there. I know the stove is going here. And so we're working on the cabinets. I don't know exactly what the cabinets are. I found some that are used that are 7 feet long, and I think we can retrofit them and add them. The point is, these cabinets at the highest point are about 5 feet. So what I'm going to do is let Tony know this, and he's going to do some blocking. And what blocking is taking some of the scrap material that you might otherwise throw away. And I've got some examples of some of this 2x material. This is a little short, but a piece like this, what they can do is they can take these pieces and cut them off where they'll go inside between these studs, all right? And so then there's really very little guesswork as to where you can drill a hole or drive a nail into this wall, and you've got a really solid, secure way to mount something heavy like cabinets. So this is called blocking. So whenever you're thinking about a house and you've got it stripped down to the stud walls like this, and you know you're going to hang a heavy mirror, you know you're going to do cabinets on the wall, you've got a big piece of art, piece of sculpture, something like that that needs support, this is the time to get it built into the stud wall. And then we're going to come back in certain areas with our finished material, our finished skin, if you will, on the inside of the house. So this is the master bathroom, and you know, we've already figured out where things are going to go. You can see by, well, the plumbing indicators. This is going to be where the shower goes. And over here's the potty, and over here's going to be the vanity. So, you know, in knowing that, I'm probably going to have some sort of mirror unit here over the vanity. I'm not sure what it is. So this is one of those situations where let's go ahead and shore it up, because we're using the scrap material anyway. It's going to be thrown out, and applying it to these walls, it's just going to make the finished work in here so much less frustrating when we can know where we can attach something to a solid wall.
So some other places where you might want to specify blocking on drawings would maybe be bathroom accessories like towel holders, things like that. If you don't have blocking, you can always use drywall anchors as well to secure those things. But if you have the opportunity to specify the blocking and just put it in there, that's great. When we talk in a few weeks about universal design and accessible design, a lot of times now in newer construction, we're seeing people planning ahead for transitioning and aging in design, aging in place. So you might specify in a bathroom design to have blocking available if grab bars need to be added at some time or something like that. It's really great if you have an opportunity to add blocking. If you're working on a project, a renovation project, and you know they're not tearing the walls open, you can also add blocking to the exterior of the wall by adding a sheet of plywood that screws into the studs and then provides you with a place where you can screw into and adhere without having to add blocking or tear the walls open as well. So blocking is really important, and it's definitely something that should be documented on the interior design drawings, since we typically are the ones that know where all of these accessory pieces or decorative pieces are going, just to make sure. And you can also see blocking in steel framing construction. So we're working on a project right now. It's a multi-family apartment project, and it's steel frame construction. But they've added wood pieces between the metal studs so that we can attach our wall cabinets for the community kitchen area and things like that. So especially in steel construction, you do need to have a dense something to attach to. You can't really drill right into metal. So making sure that you specify those blocking locations is important. Even things like TVs need blocking if you're going to hang a TV on the wall. Anything that has substantial weight to it, because drywall does not have any structural support whatsoever. If you drill a hole in it and you're not attaching to something behind it, like the structure or the stud, then you're just going to rip a big hole in your wall and it's going to be a mess. So blocking is definitely important. Any questions about blocking? And then I just want to talk about one other type of framing system that is becoming more and more common, especially in residential, are panelized wall systems. So this essentially is when the whole framing system for the wall is created in a factory, and then the whole piece is shipped to the site and they just put it up. I'm even actually seeing this in commercial design. The hotel project that we're working on, they did panelized wall systems. So all of the walls, for the most part, were prefabricated and shipped to the site and then installed. So they weren't doing all the framing in the field. This just helps save time. It's more accurate because it's all being done in a environment where they have more control over the building system. So you have less discrepancies happening, usually better, quality control for the materials that are being used. And it's environmentally friendly because there's a lot less waste because they're calculating everything, planning it all out, and then fabricating it in a factory. This video doesn't have any sound, but you'll just kind of see here how they are moving down the line in this factory to create these panelized wall systems. So everything is pre-cut and measured based on the drawings provided. And then they start assembling. Something else that's really cool about panelized systems is you can coordinate all of the electrical and plumbing and HVAC systems right into this so that they can coordinate that as they're building. So you'll see they had some electrical boxes in those walls. They put on the exterior sheathing panel, so that's already part of the wall system, doesn't have to be done in the field. They're even adding that rigid foam panel, so insulation is happening to the exterior side of this wall. So there's a lot that can be done as far as standardizing wall partitions, and then they just get shipped to the site and put up, and it makes construction so much faster when that happens because it's just so much more efficient. And here they're even adding in the windows, so all of that's prefab and done. So really, once this gets erected at the site, they can go straight into finishing, and they don't have to do a lot of actual construction framing.
Is this a lot of like the new home, new builds that are happening and they have certain models? Is this how they're doing that?
Yeah,
So,
I know for sure Oakwood Homes does it. And they've been doing it for a long time, for probably 20 years. I do think more and more residential homes are probably doing it. One reason why they only offer certain styles and floor plans typically has to do with their return on investment or building costs and how much they can sell in that area. So a lot of times the plan limitations will be based on that, but this does, I've definitely seen this in residential construction of new homes, for sure. Any other thoughts? So this is another, what I would call best practice that you might want to consider doing more research on for your best practices booklet. And then moving back towards commercial, again, structural steel framing. So a lot of commercial projects are big and have a lot of load-bearing weight that they have to support these larger buildings. So the structural steel framing is typically used. Some great things about structural steel components are you can do custom shapes, so that if you have this really cool design feature and you figure out how to support it, you can do customized structural steel framing. So if you have, like, I don't know, a cantilevered element or a big archway or something like that, that wouldn't limit itself to something that's prefabricated, structural steel is a great option. The T-beams are also used as load-bearing beams in structural steel framing. There are channels, C-shaped structural beams that you'll often see where they literally just have like the three sides. You see that a lot in interior wall framing in structural steel. There's the bearing pile, which is the H shape. And that is mostly to get those in those deeper foundations. We were talking about those drilled pier foundations. So those beams can hold a lot of weight, you know, more than 1,000 tons of weight. So they're very strong and supportive. There's the L-shaped angle or L-shaped beam. Those are great for floor system stability. And the I-beam is probably the most common, what you'll probably see most in commercial construction. It's a very universal beam. It literally looks like a capital I. It's great for resistance to force and bending and movement. And then there's the pipe, which is that's cylindrical and hollow structural steel. That's used on a lot of different projects for like utilities, gas and water and oil type projects. And then there's hollow steel section, or HSS, which is more of a tubular cross section, and they come in varying sizes and they have a very thick radius. So it's a good option. Oops, sorry, sorry, you guys. So it's a good option for construction that requires multi-directional loading or multi-directional structural support. So steel is made at a very high temperature, which gives it its strength. Steel can be kind of expensive. But in those larger buildings, you'll definitely see a lot of steel construction. We're actually right now in this hotel project, we're actually creating a faux I-beam because we wanted to have this rugged steel I-beam look throughout the lobby, and we couldn't afford the steel, so we actually are having it created in wood to look like a steel I-beam. So sometimes you can even use structural components to be decorative, depending on what the aesthetic is or vision is for the project. And then there's just like for floors, there is the light steel framing for wall systems as well in commercial projects. And again, like I was saying, we're working on that project where we have the light steel, the light gauge framing, and we've added those wood blocking pieces running horizontally between the studs so that we have places to adhere to when we're installing cabinets or other heavy images or heavy products. With using steel, you can usually get away with larger spacing between the studs. So about 24 inches on average in steel frame construction versus that 16 inches on center for traditional wood framing construction. Steel is great for building radiuses or curved walls because you can transform it and build tracks where you can build around it. So it lends itself to those types of constructions better than wood does. Again, it's non-combustible. That's why you see it in a lot of commercial buildings, is for fire prevention. And then unlike wood, it's not at risk of warping or shrinking or really changing over time. It's going to stay very consistent and remain very rigid. So any other questions about steel or light gauge steel framing? Then the last type of wall framing that you might come across, I think more so in commercial projects, but maybe in some of those desert zones, you might see some concrete or masonry wall types. So, masonry, you probably will think about brick construction, masonry construction, but a lot of times the load-bearing walls or columns could be masonry construction. There are a few different types. We've got the clay units, which are like the clay brick units that you're probably familiar with. There's glazed brick as well, concrete brick, but essentially they're all laid together with a mortar system, and then that creates the strength or the structure for the walls. The concrete masonry units or CMU blocks are also something that you will come across in a lot of commercial projects, especially in things like stairwells. You'll see a lot of CMU construction. So they're typically 8 inches by 16 inches, and they become just this great load-bearing form, and they're very good for fire resistance as well. So that's why a lot of times you'll see them in those egress stairwells where people are trying to escape during an emergency. And then the mortar, so mortar is what really holds these all together. It's the glue that binds. It's a little bit like grout for tile, but it's composed of cement and lime and sand. Sometimes they call it Portland cement. So they're usually mixed on site. Sometimes you can get pre-mixed mortars, but they usually need to be carefully reviewed to make sure that all the components are adequate so that they don't crumble or end up falling apart, because they're really holding the entire structure of the building. So in residential, you might see more, especially here in Denver, we have a lot of brick bungalow style houses that you'll see. So that would be an example of masonry wall types. Another thing that's pretty cool about some of these masonry wall types, especially with the kind of urban, lofty industrial design, is sometimes you can expose that brick on the inside and use it aesthetically with your interior design as well. So it can also just be an aesthetic thing that you add to the design. Seeing a lot of that with some of those loft types in downtown Denver, those open spaces that are in older buildings. They're kind of exposing that exterior brick and bringing it inside. Any other thoughts about framing techniques? So we're going to move into roof systems. This is a roof plan. I like this plan or this diagram because it shows you the slope of each roof shape. So you can see where the pitch will be and where the water would be draining off. There are a lot of different roof elements happening in this plan view, and a lot of different types of roofs, roof shapes are being used. So what I want to do now for the next, say, 15 minutes is have you guys break out into groups. And essentially, these are the 7 roof forms that you will most commonly see in either residential or commercial construction. And what I'd like you to do when you get into your breakout group is, and I'm not sure how many people we have. I'm trying to figure out how many, if we should do one group for each type. But when you're in your breakout group, I'd like you to define the type of roof that you have. So what are its characteristics, its uses, its framing methods, find out what the pros and cons are for the roof form, find at least one image to provide as an example of the roof form, and then provide details of how it is constructed. So we have 7 types of roofs. I think we have 16 people on right now. So I think what we'll do is we'll split this into, we'll do gable and hip for group 1, mansard and grambalt for group 2, and then these last 3, flat, shed, and butterfly for group 3. So I'm going to make 3 breakout groups, and I'm just going to let it assign you randomly. I think I have to stop sharing for a second. Oops. Stop sharing. Sorry guys, I'm trying to figure out, here we go. So I'm going to create 3 breakout rooms. And let's see. Okay, so you should all now, when I open these rooms, you should see your breakout rooms. So let's go, I'm gonna, oh, it actually gave me 7 rooms. So room 1 takes gable, room 2 takes hip, room 3 takes mansard, room 4 takes gambrel, 5 flat, 6 shed, and 7 butterfly. And I don't know if you guys want to take maybe a screenshot of this. I'm not sure that you'll be able to see the screen once you go into your groups. But just spend about 15 minutes and do some research with your group about the characteristics of your roof type, and then we'll regroup and kind of review them all together in the last 15 minutes of class. Sound good? Okay, here we go.
Can you go back to the show? Can you go back to the page that shows what group does what?
Yeah.
Yeah, that one, so I can do a screenshot.
Definitely. Everybody ready? All right. I'll see you guys in a few minutes. Did you get a group, Laura? Oh, there you go. guys. We'll give people just another second here. I didn't realize when I closed the room that it was going to give another minute. So
There was a timer going in the upper right part of our screen, and it said we had 15 minutes left. So we really didn't get done.
Oh, I'm sorry. That's okay.
It said we had 15 minutes, and then it was like, then all of a sudden it was a pop-up. Your group ends in 57 seconds. It's like, oh, well, she is.
Hey, Shell, are we going to be able to share images? Are you going, is it?
Yeah, I think you can share your screen. So
Okay. I tried earlier and it said it was disabled, so I just want to make sure I can now.
okay, well, we're going to experiment here. So, and don't worry if you didn't get it all done. We can talk about it. And I've got more slides that I can post on D2L as well. So let's start with group 1 and the gable roof. Let me know if you can, someone can share their screen from that group.
I'm trying, but it says that I am disabled.
Okay, hold on one second. Oh, maybe I have to stop sharing mine.
I'll try.
I'll try.
Not yet.
Yeah. Technology. More. Trying to see how I can get you able to share your screen.
And I drew a picture, but then my background won't allow it to show up.
Make host.
Okay. There we go. Where's my text?
It should be.
Sorry, everyone.
It's okay. We're all just figuring this out.
Oh, this thing always gets stuck on there. There we go. Ah. Again?
So a gable roof has at least one flat end called the gable. This triangular end is not composed of roof materials. Instead, it is made of siding, stone, or whatever materials are used on the rest of the home's exterior. A gable roof can have 1, 2, or more gables, and they are most common in cold climates. Their uses, they're structured to shed water and snow. The steep pitch of gable roofs allows for excellent water drainage and fewer leaks. They also allow for more ventilation and provide more space for an attic or vaulted ceilings.
Great.
And just the pros and cons, what she was just saying, that the sloped obviously drains better than most other roofs, so it lowers maintenance costs. Dormers can be added on these if the space is like a living space instead of an attic, so you can have actual windows and light come in. And they provide more headspace in storage areas through the middle. You can use trusses, which increase the live load and help with labor costs, since the trusses are usually prefabbed. The cons are that the framing is more complicated than most flat roofs and more costly. If used over a living space, the headroom is limited on the edges of the room. Needs to be better insulated because the amount of space, so that's more costly, and there can be sagging if they're not properly supported with a good subroof.
Great. Are they typically constructed wood framing with trusses, or did you get into that by chance?
I found rafters and dormers.
Okay. Yep. One other con about gable roofs is that they can be problematic in high wind and hurricane areas. If they're not constructed properly with adequate support, they can also collapse. So those rafters and trusses help provide that type of support. Good job, guys. Any other information you want to share?
Cover that it's usually like a great snow roof.
Yeah, they are.
Okay.
You do see a lot of gable roofs here in Colorado because of our snowfall. They help snow slide off the roof. All right, group 2. Let me see who in group 2 wants to be there. Susan.
We didn't really discuss who was going to talk. I can hear your screen.
That's okay. I don't know if I still have the breakout groups thing open, so I don't even know who was in group 2. So just let me know.
I was in group 2 as well, so
Yeah.
I can.
Okay, let's see.
Yeah. And then I'm on an iPad, so I can't really share my screen though.
I can share my screen.
Okay,
I've already
cool.
got it pulled up.
Did I get the screen taken away from Tanis? Did you get something that said, oh, you're muted.
I stopped sharing.
Okay. See if I can get this. Yeah.
She might have to make you host again.
Yeah, you might need to make me host again because I lost my permission.
How do I make you host? Is it under more?
Yeah, like on the 3 dots, if you click on my image, maybe the 3 dots, and then it'll say make host. Or right click.
Right click it on my 3 dots under more. It just says breakout rooms. Wait, let me see.
Oh, I can reclaim it. Here it is.
You got it.
Okay.
Hi, Angela.
Hi, I got lost somehow. I lost connection to the class.
Okay, well, we just went over gable. Now we're going to go over hip roofs.
Okay, thank you. Sorry.
I think I just gave Jess the control.
You did. Can you see my screen? Yeah.
Mm-hmm.
Okay. I feel like we found a lot of good information.
I'm breaking up a little bit.
Oh, my internet connection sucks. Better?
Yeah.
Okay. I was just saying that I think we found a lot of good information. Definitely some conflicting information.
Okay.
But so the definition is a hipped roof is a type of roof where all sides slope downwards to the walls, usually with a fairly gentle slope, has no gables. So as you can see in the picture, it just kind of goes down. So this makes it beneficial in high wind areas and areas with snow and ice, just like a gabled roof, because it just goes.
Right.
Yeah. I can also add to that with like how it's built. So you can kind of see the rafters going up towards those hip joints, towards the hip rafters, and the hip rafters all meet at the top at one point. Well, in this case, 2 points, it depends the shape, but it's that long center beam, the ridge beam, that's always over the center of the rectangle of your room, building, whatever it's housing, I guess. And then some advantages to this are it is more expensive, but it also, we found conflicting information on this where it was either easier to ventilate or harder to ventilate. So the jury's out. And if you have any input on that, that'd be great. And then also there's obviously no vertical end. It does take more building materials. So that's more than likely why it is more expensive to build, but it's also more stable, which is important because especially depending on like the region that you're using it in, it can be really detrimental, especially if you're in a hurricane area. And then it's also easily adjustable to allow accessibility depending on what your space is underneath that.
Great. Yeah, I have, there's a lot of hip roofs in Colorado, my neighborhood particularly. I swear almost every other house is a hip roof. You touched on that they're more expensive and more complex in design to require more building materials. And they do have additional seams that can make it easier for water leaks or more opportunities for water leaks since you're attaching more components if it's not installed properly. So, but yep, overall great job on the hip roof. So group 3, who is in group 3?
Me and BJ, you can share, let me to share mine, I think.
Okay.
Sherry. Can I? Okay.
Getting better at this.
Well, we'll see if I am.
You didn't know you were going to learn about how to navigate through Zoom today, too.
Right? Oh gosh, I have to, can you see mine? Not yet.
Down at the bottom of your, there should be like a green button that says share screen.
Yeah, I had a little notification saying I have to change my security settings. Dang it.
Oh.
Sorry, guys. If I allow it here.
About what you found, and then I can always show a picture of a mansard roof as well.
Yes. I think I'm almost there. We did. Gosh. Can you see me?
I can see you.
Oh, just me? Okay. We did mansard roof. It is French. It has, I have some great pictures. It has 2 slopes on all 4 sides, and it's super duper steep. So they were first created in the 16th century. It's also called a curb roof or a French roof. Advantages, it gives you more space to work with. It provides more light and better heat distribution. Also can save some cost. You don't have to build a separate attic. You can use quite a bit of vertical space on the interior because they're almost vertical slopes. BJ, do you want to maybe do disadvantages?
Sure. So one disadvantage was just the challenges with local laws around this type of roof and whether your roof can be that high. It requires a lot of materials and labor, so there's high installation costs and it takes a long time to build. And then it's not very good for weather resistance. So for snow and rain, a lot of that's going to get caught up on the very top of the roof. And it also has very high maintenance and repair costs.
Nope.
And we struggled to find anything that really detailed the framing of this one.
Okay, yeah, I can see that. Here's I'm going to reclaim the host and I'm going to just share so you can see, you can all see what a mansard roof looks like. You may have seen some of these around in older neighborhoods in Denver. So just like Sherry was saying, kind of that vertical flat front face of the roof, almost completely vertical before it pitches up to more of that gable style. And another thing about these are a lot of times you will see dormers or windows because you have so much added living space in the roof itself. So that's the mansard. Who was the next group is the gambrel. Who's group 4? Did we lose group 4?
It was me and Emily.
Oh, okay. Who wants to share it?
I don't know. Emily, do you want to talk about it really quick? I found a cool video that just shows the math of it that I thought was interesting.
Yeah, I'll talk about it.
Okay.
So the gambrel is very similar to the mansard. It's a two-sided roof with 2 slopes on each side. It's also known as a Dutch roof. And the upper slope is positioned at a shallow angle, while the lower angle is steep. It's mostly used for barns and sheds nowadays. And it's made of rafters that are made from 4 sections of plywood, and gussets are attached to the joints. And you construct the entire piece first, and then you attach it to the walls. And then you cover the roof with plywood. The pros are it provides the advantages of sloped roof while maximizing headroom inside the building's upper level. And the cons are just that it's more expensive because it requires a lot of materials. And it's time consuming to assemble. It's a lot of pieces. That's it.
In this video, I will be providing you with another method that can be used to calculate the rafters and the design for a gambrel roof. Now, this particular roof right here is from a video I made over a year ago, and I will put a link at the top here if you want to check that one out to see if that will work for you. This one here is quite simple. It's not too difficult, but
Catherine, before we go too far in this video,
the book that I have and thought it would be interesting.
Hang on a minute.
it's like a 7-minute long video, so I just wanted to make sure we saw it.
It's not the one I thought it was.
Oh.
Hang on. It was really fast, but.
He laid those rafters out on the floor there.
It's basically a barn-shaped roof, but this one was giving you some really cool, a really simple way to do the math. But with all this zoom on here, I got screens everywhere.
No worries.
All right, hold
You
on.
can always post it to the muddiest point or something too.
I'll get it to where it's actually doable on this thing. Let me figure out how to.
Okay, while you do that, I'm going to take back the hose.
God, I'm dizzy.
I'm going to quickly share a picture of the gambrel roof. So it is really that farmhouse barn style roof. The gambrel construction only uses 2 roof beams along with the gusset joints, so it's quite simple construction. Fewer materials are really needed. It is not great for snowfall or heavy wind areas. Same thing with the hip roof. If it's not constructed well, it could be prone to leaks because of all the connection joints. And you do get that extra, just like the mansard, you get a lot of that extra living space in the roof area itself and extra light. So who's group 5, flat roofs? Who was group 5?
That was me and Jen.
Okay. And do you have
I can share my screen.
Okay.
It would be helpful, or we don't have to.
Oh yeah, hold on 1 second. There you go.
Katie, did you find some pictures?
Yeah.
Okay, because I rewrote everything.
Can you see those two?
Yeah, I see them. They're cool.
Okay. This is the construction method on the right. So it actually, on the left,
That's what a flat roof looks like. It's pretty much what the name implies. It is a flat roof. With a pitch that has no more than 10 degrees of an angle to its slope. Some of its characteristics is that it's flat. What else? Jen, do you want to speak to any of the characteristics?
Sure. I did uses, pros and cons, and then materials. So materials, the flat roofs, what I read was there's 3 different types of materials used for the flat roof. One is hot tar and gravel. One is single ply rolled roof, which is called modified bitumen. And then a rubber membrane is a different kind, the third kind. The construction, she's got it there. Basically, what I read is it's a ceiling nailed to joists which support a deck. And then there's a waterproof vapor barrier, then insulation, and then whichever roof board material of the 3 I just mentioned. Uses, arid climates mostly, commercial or modern residential, inexpensive extensions of houses, sheds, buildings you want to have blocked sunlight, or increase outdoor living space. Oh, and I did mention if there's height restrictions, like residentially, which is a great, Katie's example there is perfect for that. So, if you have height restrictions, maybe in the neighborhood or commercially, flat roofs are great for that.
Yeah, and we came up with one disadvantage is obviously snow. There is a drainage system, but in a climate like ours, it wouldn't do very well with all the load on a single flat roof. So it wouldn't be recommended as much in our climate.
Yeah, it can't hold as much weight for sure. Yeah. It's not as stable. There's hardly any room for insulation. I think that's a huge one, which is probably why they say mostly arid climates, I'm guessing.
Yeah.
Yeah. Pros, I guess I said a couple of them, but maybe inexpensive, fewer building materials, super quick to put up, easy to maintain, easy to replace. I don't know.
Yep, I think you guys got it. There are a lot of commercial properties that utilize flat roofs, so it's most commonly seen in commercial or industrial. And I think you covered everything else. Also, another pro is that you can, they're really conducive to installing solar panel systems for natural energy sources.
Oh, I know. Just sustainability, or maybe it's just less of an impact on our footprint with hard surfaces and impervious surfaces would be, you can build a garden on it. You can make it a living roof, not just a living space, but you can make that.
Shell, I have a commercial building and they have rocks on top of their flat building, like on top of their flat roof. They have a whole bunch of different, like a layer of rocks. Would that be for the drainage system or?
Potentially, or to do with trying to cool the roof material so too much heat isn't being captured through the roof into the building.
That makes sense. It's a manufacturing building, so that makes sense.
Yeah.
So who is group 6? I know we're a little over time, so if you guys need to go, please don't worry about that.
Tabor and I are.
Okay, hi, we'll be quick. So, do you want to share your screen, Lisa?
Yeah.
Okay. Shall I talk first?
Yeah, go ahead.
Okay. So sheds, I think we're all familiar with sheds and what they look like. And some of the requirements to make a shed roof is that it's waterproof. Usually, and the shingles on the shed are the same as a house. There needs to be a pitch in the shed that is at least 6 degrees. And there needs to be ventilation only if the walls of the shed are are insulated. So there's a few framing options you can go with a shed. Either you could have it insulated or not insulated, and that goes along with the ventilation requirement as well. There's flexible roofing options. There could be tile roofing, corrugated sheet roofing, and then also fiberglass. So some of the pros is that it's very affordable. The roofing tile is, or whatever roofing you go with, is usually an affordable option. Various different materials can be used to create the shed. It's a lot more flexible in what materials can be used. And it also can be used to install solar panels. So definitely green, and it can actually be as green that the roof can be a living plant or a green roof. And Lisa, do you want to talk about that?
Well, I mean, I guess I don't really know a ton about it other than the pictures that are here. You can literally put plants on the roof. I don't really know why would be a good option, but maybe Shell knows. And I was just reading while you guys were doing some research. Normally they're a single slope, I believe. I mean, obviously some other sheds have, like your shed at home has 2 slopes to it. But the first shed roof was recorded back in 1730 to the 1740s. And you cannot use, it's not a good idea to use a shed roof for like a large home space area. I don't know what else we're missing.
Okay, I think just one more pro was that shed roofs prevent the pooling of water at that 6-degree angle. So it's not flat. It will always hopefully drain the water down. Some of the cons is connected with that draining of water at a 6-degree angle. There is a need for boxed gutters. So the gutters actually need to be doubled to catch all that water that's coming down in one direction. Another con is that a lot of people don't find it appealing and aesthetically appealing as a regular roof. And let's see, and like Lisa said, you can't use it for larger homes.
Yep, that all sounds good. I have actually a photo here I'll share of a home with a shed roof. So the thing about shed roofs is they can be a steeper slope and more dramatic. When you do have this dramatic of a slope, it does create interesting situations on the interior because you have areas that are much lower in ceiling to this much higher, more vaulted area. Those are the only things I would add to what you guys already said. And then last but not least, the butterfly roof. So who's the butterfly roof?
That's Grace and I.
Okay, which one of you would like to share?
I can, I don't need to share, but I'll just switch my camera so I can show you the pictures because it's on my computer.
Oh, okay.
Yeah, give me 1 second. Can you guys see? Sorry, I don't know what. Oh, I'm blocking it.
Yeah, and your background is making it visible.
Oh, sorry. Okay, let me take it off. Okay, so that's a picture of a butterfly roof, or it's also known as a V roof. It's basically an inverted version of a standard roof. And it's 2 roof surfaces that slope down from opposing edges to a valley near the middle of the roof. And The uses, originally it was designed to catch rainwater, and it's associated with mid-century modern architecture in the US. And let's see.
I can talk about the pros and cons if you want.
Okay, great.
So when you look at these roofs, my first thought was the water is going to just run straight to the middle, but that is the point, to collect water. So that's one of the main pros, is that you can collect water and use it. So this would lend well to a green home or off the grid home where you were going to have your own water source. It's also very wind resistant. And on the sides of the home where the roof is higher, you can have larger windows and higher ceilings. But as we said, the water runs to the middle, so drainage can be a problem, and they are expensive to build.
Very good. One other con I would add would be sometimes with those open ends or the higher, taller windows can make it more difficult to regulate the temperature inside the building. So some areas might be getting more thermal distribution than others because of the sun's ray coming through those windows. But overall, very good. Okay, let me share my screen one more time. We're okay. Can you all see my screen again? Okay, so great, good. That was good exercise and discussion. Thanks for doing that on the fly there and working through Zoom. This is the terminology page for this week, so please feel free to review it. For our assignment this week, we're doing our first 321 assignment, so it's going to be the building envelope. It is in the assignment section or also in the weekly module under content. The instructions are there in the assignment. You can submit this just as a text submission to the assignment folder, or you can attach a document if you so choose. That'll be due Sunday, 2/14 by 11:59 p.m. So again, it'll be 3 prompts. That's the basis of the 321. So it'll be 3 things and then 2 things and then 1 other thing that I want you to discuss from what we talked about this week. It's not a discussion, so you don't need to be able to see anyone else's responses or reply to anyone else. You just need to submit to the assignment folder. Next week, we're going to be talking about systems, and we'll be reading chapters. I know this looks like a lot of reading again. Chapters 5, 13, 14, 16, and 17 in the NKBA book, or chapters 2 and 5 in the optional DGBCS book. So we'll be talking about energy conservation and systems used in construction next week. So be prepared for that. Otherwise, I don't have anything else for you. Next week, I'm trying to get some more information together for those of you who are talking about looking at alternate service opportunities. So hopefully I'll have some more information put together that we can discuss at the beginning of class next week. But any other questions or thoughts or concerns about anything for this week? Okay. Thanks for staying on a little bit later. Sorry we went over on time, but feel free to reach out if you have questions or something comes up during the week or you need any help. I'm always here. So have a great week, you guys, and I will see you next Monday.